Hi there. Thanks for joining us on the latest episode of Space Nuts. My name is Andrew Dunkley. It's great to have your company. Coming up on this episode, we're going to be talking massive solar flares. We're going to be talking 1,000 days on Mars for Perseverance. NASA's got a fabulous idea to move around faster in space. It's called a plasma rocket. And the biggest ever protoplanetary disk pile of junk stuff that makes planets ever seen. We'll talk about all of that and more on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's here again because he's got nothing better to do. Fred Watson, astronomer at large. Hello, Fred.
Yes, that might be true soon. You never know.
Taking dogs to vets and cleaning up dog stuff.
Yes, that's right. No, it's and I'm being reviewed, of course, by the
By the Prime Minister? No, maybe not that high.
He's not quite put his oar into it yet, but you never know.
He's been too busy with the budget.
I think the budget
Just probably why you're being reviewed.
Might be, yes, that's right. It might be.
Everything else okay, though, Fred? Aside from budgets and reviews and dog stuff?
Dog stuff, yes. That's the dog is suffering from a gastric episode that Letty wound up at the vet's very, very early this morning, at the emergency vet, but he seems to be okay. So hopefully it's not anything that's life-threatening. We were a bit worried for a little while, though, I have to say.
Yeah, that's the thing with pets. They tend to rack up vet bills at a rate of knots sometimes.
Yeah, that wasn't why we were worried. We were worried in case we didn't.
No, I know. Yeah, it's very costly. My son had to take his one of his cats to the vet a couple of weeks ago. $1,200 worth of dental work.
Yeah, I can imagine.
Yeah, very, very scary. We don't have any pets anymore. We just
run out of money.
Well, that's probably the reason. Yes. But yeah, I think we've had our fair share of cats and dogs and fish and everything else.
Yeah.
That's not what we're here to talk about. I did want to start off, Fred, by having a chat about this latest activity from the sun, which has resulted in some massive activity. It's sort of reaching the peak of its 11-year cycle, as far as I understand it, according to NOAA anyway. But the biggest solar flare in nearly a decade has just passed over the Earth, and some of the photographs of the aurorae north and south have been extraordinary. It's really been quite a spectacular thing, notwithstanding, obviously, the potential side effects of such an event.
Yes, that's right. I think it was actually a coronal mass ejection.
Okay.
Rather than a flare.
Yeah,
but I might be wrong.
They're using the description solar flare in some media outlets, but that might be a bit of creative license.
The stuff I read, and it's a few days ago now, is a G4 coronal mass ejection.
Right.
G5 is the biggest.
Yeah.
And so, I mean, whatever it was, it hurled a whole lot of plasma and subatomic particles and magnetic fields at the Earth from the direction of the sun. And we bathed in the aurora. That's absolutely right. My friends and relatives all over the world have been sending marvellous pictures of auroral displays, even as far as the south of England. Friends there sent pictures, and I think probably even further south than that. Here in Australia, there was a report of aurorae being seen. This was, I think, Friday night or maybe early Saturday morning, the weekend that's just passed, at Siding Spring Observatory, where the Anglo-Australian telescope is. That's 100-odd kilometres further north than you are.
Yes.
Which means it's a long, long way from the polar region. But
there have been reports that people have seen them from Dubbo, which is in central New South Wales, which is usually way too far north to see anything like that.
Yeah.
But the weather was so bad here last weekend, I didn't bother to try.
Same in Sydney. Sydney's been under cloud and rain for about 2 weeks. It's sort of cleared away now, but not before it blocked out any views at all of the biggest solar event for 20 years, the best aurora for 20 years. So we missed out on them, which is a shame. I think the ones 20 years ago, 2003 was the last big display of this kind. And I pretty sure that's one that I saw from the centre of Edinburgh, city centre. I could see the aurora. It was quite extraordinary.
Of course, the big worry is the impact these things have on electronics, and that's constantly being monitored, and warnings are issued whenever there are potential blackout zones, and there have been some. There have been many in recent years. It just depends on what part of the planet the thing hits. A direct hit, though, could be catastrophic in some circumstances.
As was the Carrington event.
I haven't heard of anything too negative happening. Yeah, the Carrington event when the telegraph was,
it was 1859, I think. 1859, I think, the Carrington event, and we've not seen anything as strong as that since then. But something like that could happen. There's no guarantee that the sun won't send out a gigantic burp. And at the time when that's likely to happen, of course, is when we have solar maximum, where the maximum of the sun's activity, which is kind of where we are now at the moment.
Yeah, it's reaching its 11-year peak, and then it will start declining, and then it'll go to sleep for a while, and then it'll all happen over again. Yeah, I think it's fascinating. I know they study the sun, and they've got observatories sort of taking long, hard looks at it all the time to learn as much as we can. But these kinds of events are... well, they're spectacular to the observer, but they could be catastrophic for satellites. I do believe they actually did have to shut down some satellites to try and preserve them because of this event. Okay, let's move on, Fred. And this is to do with Mars, which is the subject of much study as well. And Perseverance is now past 1,000 days on the Red Planet. Now, I just need to clarify, is it 1,000 Earth days or 1,000 sols?
Yeah, it's 1,000 days.
Right.
And you're right. One sol, which is a Martian day, is 24 hours and 40 minutes, just about. So it's much the same. It's quite extraordinary. A bit of a coincidence that the Martian day and our day should be so similar. Likewise, another coincidence in that the axial tilt of the two planets is very similar as well. We're at 23.5 degrees tilted over, and Mars is about 25 degrees. And that's quite, I think, remarkable that those two should be so similar, yes.
Amazing.
Anyway, so it was July 2020 when the Perseverance vehicle was launched from Earth, launched from Cape Canaveral. That would have been something to watch. I'm sorry I wasn't there to see that. And then landed at Jezero Crater in February 2021 after a 7-month journey. And that area was chosen because it's believed that it is a crater, but that it was once an ancient lake bed. And the evidence for that is a delta. There's evidence of a river that flowed into the crater and another one that flowed out, actually. And where the entry point was, there is a large amount of debris covering a wide area, which is a delta. It's where the river has brought down sediment from further upstream and dumped it on the bed of the lake. It's a bit like the Nile Delta, the Rhone Delta in France. So a place that was well chosen to be representative of where you might find remnants of living organisms. And by that I mean fossilized remnants, because there may have been microbes in that debris that was washed down and then dumped on the floor of Jezero Crater. So,
sorry, I thought
I thought you were going to ask a question, but I'll wait for that in a minute. Who are these two? They're not very professional, are they?
No, terrible.
So, as you know, because we've discussed it many times before, of course, that mission has been characterized in a stunningly effective way by the fact that Perseverance also had a little friend called Ingenuity, the helicopter, which did marvelous things in terms of imagery and detecting where you could go and where you can't go with a rover. broke a rotor on its 73rd mission after an expected lifetime of 5 flights. I think it was either 72 or 73. I think it was 73. And the evidence is there. There's an image that's been well circulated that shows poor little Perseverance with Ingenuity with its broken rotor, and the bit that's broken off is, 15 meters away or something like that. So, but so effective and such a stunning success in terms of aerodynamic design for aerial vehicles on Mars. And the other thing it's done is, because its mission is to look for signs of past life.
Yes.
Now, there's a limit as to how much you can do of that with a robotic laboratory on 6 wheels, which is what Perseverance is. But in order to make better sense of it all, as you know, there have been little caches of material basically in small metal canisters. Basically rock samples, soil samples have been put into, I think it's 23 so far of these canisters, and then deposited on the surface for later collection by a robotic machine that is currently still in planning, if not necessarily in development. I don't think it's going to be before the end of the decade that mission takes place, but it will be fantastic when it does, to bring those samples back and analyze them in earthly laboratories and maybe find evidence of fossilized microbes.
Yes, that would be exciting. I think one of the most interesting samples they collected was one they believe contains silica, fine-grained silica.
Yep.
Which is known on Earth to have preserved fossils in it. So that's one sample they'll probably be very, very keen to get their hands on.
Indeed, that's right. And another of them has phosphates in it. And again, phosphates on Earth are associated with biology, basically, with biological processes. So those are going to be really interesting samples to bring back. There is an instrument on board which is called Pixel, Pixl. It is the Planetary Instrument for X-ray Lithochemistry. And that is a way of, using X-rays to see if there is any kind of, fossil remnants, anything that looks like a fossil, any chemical changes that might have been the result of microbial activity. So there is equipment on board that can detect that, but so far nothing has been seen that could be attributed to signs of life. So far, no Martians, but still a good future for those samples that have been left behind on Mars, which we hope one day to be able to talk about on Space Notes when they come back to an earthly laboratory. Yeah,
the one day thing is, I think, the most frustrating element of this, because that they didn't have a retrieval plan proper. They just said, we'll get to it one day.
It was worse than that, really, because they did have one, but NASA's decided it's too expensive because the estimate was $7 to $13 billion. So no, $8 to $13 billion was the estimate, and they're being told to revamp everything so it doesn't cost any more than $7 billion, which is still pretty expensive for something like that.
You should just donate the annual interest from your bank account. That'll cover it.
Oh, that will cover it. Yeah, I guess I could do that, couldn't I? Yeah,
from all your book royalties.
Yeah, the book royalties. Yeah, now you're talking. I once installed central heating in our attic on the strength of a book royalty.
Did you really?
That's the kind of level that you get. Yes.
Yeah, I think my first book, which was an audio book, the royalties there covered a holiday, I think.
Well, that's pretty good. That's better than the central heating. The air conditioning, not central heating. Yeah.
Well, no, let me qualify it. It was a really crap holiday. No,
it was crap air conditioning as well.
No, that's quite a while ago. That's a decade ago now that book was published. That was the one about my grandfather in World War I.
Yes, I remember it.
Yeah. I've since discovered, which I didn't know, and this I attribute to Taylor Swift, but the way that deal was set up, the ABC owns the rights to the distribution, etc., of the book. But if I do what Taylor Swift did and release Andrew's version, I can re-release the audio again under my distribution rights.
There you go. Sure, Australian law would let you do that?
I'm still checking.
I know. Because there's a similar... I'm not betraying any confidences here, but I work with a very well-known composer. He's a good friend. He writes music. I write the words. This is classical music.
It's Barry Manilow.
That's
Barry Manilow.
Yeah. But there was a similar issue with getting back copyright from some of his earlier works because he wasn't happy with the publishing company, and it was a legal nightmare to do it. Absolutely.
Well, it absolutely is. And I did approach the ABC to buy back my rights, and they said, well, how many are you going to sell? And then we'll work out the price. And I went, how do I forecast that?
Yeah.
So I just said, look, don't worry about it. It really doesn't matter that much. Have we finished with Perseverance? There'll be a book about that one day.
I'm sorry, we have wandered off the topic here.
That's okay.
But I think we've finished with Perseverance. It will be marvellous when that sample return mission does come back to Earth with its samples, and there will be great excitement, especially if something, pointing towards the possibility of ancient life on Mars is discovered. That would be the discovery of the century, probably.
Yes, absolutely. Totally agree, and let's hope so. And you can chase up that story about Perseverance at universetoday.com. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Now let's take a little break from the show to tell you about our sponsor, NordVPN. Now, not so long ago, I did a bit of a speed test, just ad hoc speed test. Didn't plan it, just went ahead and did it on the spot to prove that you do not lose very much speed using NordVPN on your desktop computer or your laptop for that matter. I thought I'd test it on my mobile device, which I haven't done in recent times. So I've got my phone here. I've got the speed test icon going. So I'll do a speed test without using NordVPN. So here we go. And it is connecting and doing what it does. Boom. Okay, there's it peaked at 135, but it's hanging around the 115, 116 mark. Oh, now it's jumped up to 140. That's well above what I pay for. But that's okay. The download, is 140 megabits per second. And it is uploading at around 4 megabits per second, which is, not really great, but that's the mobile network that's available to me, so I can't do much about it. By the way, I've only got 2 bars on a 5G network. So I'm going to close that. Then I'm going to connect NordVPN to my phone. It will figure out what it wants to do. It wants me to configure everything on the phone. Done. Okay, it is now connected to a server in Central Australia, probably Alice Springs. That's what it chose. So let's do another speed test. And we are ready to go via NordVPN this time. And I'll hit go and we'll see what happens. So this is going via Central Australia. And I'm still achieving speeds of about 70 to 80 megabits per second. I am losing a bit, but it's not a lot. That's still really good speeds on a mobile network. The upload speed is actually faster. My upload speed is pushing up towards 10 megabits per second. Now it's just hitting 11. So with NordVPN, I lose a bit on the download, but I gain almost double on the upload, which is extraordinary. Now, they've been our sponsor for quite some time. I use all their products. I've signed up. There's a special URL if you're interested in looking at NordVPN as a Space Nuts listener, which starts with a 30-day money-back guarantee. They back their product 100%. And if you go to the URL nordvpn.com/spacenuts, that's nordvpn.com/spacenuts, and click on Get the Deal, you can see all the different options available to you. And the longer you sign up for them, the lower it costs on a month-by-month basis, but you can pay for it in one hit if you prefer. And with every deal, an extra 4 months is what you get from NordVPN as a Space Nuts listener, an extra 4 months. And they back their products, not just the high-speed VPN, but the malware protection, the tracker, ad blocker, cross-platform password manager. That's my favourite thing in the world. The data breach scanner and a terabyte of cloud storage. Depending on which plan you get, you can combine all those things. So nordvpn.com/spacenuts is where you go, and check out the deal today. You won't regret signing up with NordVPN. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, this is a story that kind of tickled my fancy in the last week because we in our next episode there's a question that sort of references a situation like this, and that is how fast you can travel through space. At the moment, we are limited by certain technologies, but NASA and other organizations are working on better, faster ways of traveling through space. And NASA's very excited by this one. It's a proposed plasma rocket, which would cut the travel time to Mars from 9 months to 2 months. This is not science fiction. This is something that they're actually putting money into. It sounds very exciting.
Yes, that's right. It comes from NASA's Innovative Advanced Concepts program, which is, it's kind of blue sky research on things that may one day come to fruition and actually make a difference. And certainly, if you can get to Mars in 2 months, that's a lot better than 9 months. 6 months is 6 to 9 months is what we expect it to take to get to Mars with current technology, and dropping that by a third or more would be really significant. So it is basically, it's called a pulse plasma propulsion system, pulse plasma propulsion. There you go, 3 Ps.
Yeah,
and it in fact is built or developed from an older version back in 2018. That was something with the delightful name of Puff. Which is kind of what it does out the back end, I guess. Puff to drive the thing along. Puff is a sort of acronym for pulsed fission fusion, and it's actually a development of something that's used in the laboratory, something that compresses plasmas in the laboratory to very high pressures for short times. So the idea behind Puff was that you utilize that sort of technology, but you also provide an exhaust pipe. So you get this high pressure, but then you blast it out and it produces thrust. The new version is apparently smaller and simpler than that, and apparently also more affordable. And that but the main thing is it's got very, very high efficiency. That's the trick, and it has a very high, what's called a specific impulse, which is a term that rocket engineers use to measure the effectiveness of a rocket. And I think with conventional technology, I'm sort of pulling things from the back of my brain now, I think the highest specific impulse conventional rocket would be hydrogen and oxygen. I think I'm right in saying that, which is what they used on the Space Shuttle main engines.
Right.
And in fact, we'll use also on Artemis on the SLS, is that the Space Launch System that's being used for Artemis?
Yeah.
So that high efficiency is well surpassed by the idea of this propulsion system. We've got a figure here from an article that's on Gizmodo, actually, with some quite nice details in it. 100,000 newtons of force, a newton being the international recognized unit of force. It's in pounds, 22,481 pounds. That's pretty impressive. That is actually 10 tons. So that's I mean, it's I guess they're talking about a specific size of pulse plasma propulsion system when they quote those figures, because not all drive systems are the same. But that is pretty impressive for something that has such high fuel efficiency. So that might be the way that we are going to Mars in a few decades, taking 2 months rather than 9 months.
Yeah, absolutely. And that could be a huge game changer.
Yeah.
Huge game changer.
That's right. I mean, 2 months, 9 months with your colleagues in a space capsule, even if they protect you from the radiation and all the rest of it, you're going to be a bit sick of them after 9 months. After 2 months, you might only still be getting on quite well with your colleagues.
I don't know. When we have to drive to Queensland, you sort of get out of town and you're excited about the trip, and then, you've travelled 100 Ks and going, oh, when is this going to end? I just don't see. I don't know how they're going to do 2 months, let alone, potentially 6 to 9 months.
Yeah.
And the body odour. Let's not go there.
Was it Buzz Aldrin who suggested you should be sending old married couples out to Mars because they've done all their bickering, and they've arrived at a place where they're not likely to fall out with each other in any
the other big advantage is that they're capable of not talking to each other for long periods of time.
Yeah, that's right.
So there's all sorts of benefits to sending a married couple to Mars.
Yeah, yeah, that's right.
It could also end up in the first ever divorce on Mars. So there's all sorts of things, all sorts of firsts achievable. But yeah, the quicker the trip, the better, I suppose.
I think that's right. That's the bottom line.
I'm not sure they'll have this developed in time for the first human mission to Mars, but we've still got probably at least a decade, maybe more, probably more.
I reckon it's going to be more. That's right.
Yeah. I know they were talking 2035 or something?
Yeah, 2035. It's one of the windows, because remember, we've got to have Mars and the Earth in the right place, which happens every 2 years and 2 months. But there's a window in 2035, and that was commonly being touted as when we might go, but I suspect it's likely to be later in the decade.
Indeed, but if you want to read about this concept, the plasma rocket with the what did they call it? It had a funny name. The puff.
Puff, yeah,
the Z pinch.
The Z pinch. That's right.
The process to produce the thrust. Oh, for you Americans, Z pinch. Just in case you didn't understand what I was talking about, but tongue in cheek. Z pinch, Z pinch is the process for creating bursts of thrust on this particular engine that they're developing. Gizmodo is the website if you want to take a look at that. Finally, Fred, we're going to look at planet formation, and this one is exciting because they've found the biggest pile of junk yet seen in the form of a planet-creating environment.
That's right. Yeah, it's not necessarily junk. It's just the raw material of planets. But it's.
I don't know. Have you seen a house before they build it? That's a pile of junk.
Yes, that's certainly true. And bits of ours are like that now with these renovations that are still in progress after 7 months, 8 months now. Yeah. Never mind. We're not counting. Who's counting?
I worry for the future, Fred, when archaeologists start digging down and finding our houses and going, oh, look, they built elaborate houses. And then they dig deeper and go, oh my gosh, these builders were filthy, disgusting. Yeah. Look at this food. Look at these. Yeah.
Actually, our builders.
I found a Coke can inside my wall.
Oh, there you go. I'm not surprised to hear that. Yeah, Coke cans get everywhere. Inside your wall, I like that. What were you doing inside your wall?
A piece fell off. It was actually it was a retaining wall. I should clarify, a retaining wall. Yeah, but still.
Anyway, notwithstanding all that, this has been a very digressive sort of podcast. And so we apologise to all you listeners there. If you want some astronomy or space science, you might have to go and look at another one. Anyway,
it's like we have your head against a brick wall, really, isn't it?
Yeah, in case you find a Coke tin inside. The story here is about. I've actually got the original paper here in front of me, which is entitled High-Resolution Pan-STARRS and SMA Observations of IRAS 23077 plus 6701. a giant edge-on protoplanetary disk. And that last bit is the important bit, because what we're seeing is a star which has a sort of cloud of debris, nebulosity around it, which basically has a dark line through it. It looks, I guess it's a bit like a burger scene edge on, with the buns being bright and the dark, whatever's in the middle being dark. And what that dark stuff is a disk of material which is swirling around a young planet, basically a newborn planet, probably only a few tens of millions of years old. It's a star that's been observed before. It was spotted in the infrared. That's why it's got an IRAS number, the infrared astronomy satellite, I think it was. A very venerable machine that did a lot for infrared astronomy. It was spotted back in 2016. It's about 1,000 light years away as the crow flies. It has new observations, though, that have been made, demonstrating that this protoplanetary disk, which we only see as a kind of a silhouette sideways on, is something like 3,300 times 3,300 astronomical units. An astronomical unit is the distance between the Earth and the Sun, so it's big. It's 3,300 times the diameter is 3,300 times the distance from the Earth to the Sun. Wow. And that means there's plenty of debris there from which planets will form. So, when things settle down in maybe 10 or 15 million years or so, we might have some of the biggest planets that have been observed, and perhaps many of them, because it is so it's so prolific or so replete with planetary material.
10 or 15 billion years, did you say?
No, million.
Million.
No, we don't have to wait that long, Andrew. No.
Oh, okay. I'm going to set my alarm.
Yeah. It's like that edge. The only joke astronomers ever tell about. I think we've just blown it though. About two astronomers talking on a bus, and one saying, you do know that in 2.5 million years we're going to smash into the Andromeda galaxy. No, that's not the answer. I've spoiled the joke. You do know that in 2.5 billion years, 2.5 billion years, we're going to smash into the Andromeda galaxy. And there's somebody sitting behind taps them on the shoulder and say, "What did you say?" And they said, "In 2.5 billion years, we'll smash into the Andromeda galaxy." And the person behind says, "Oh, thank God for that. I thought you said 2.5 million years."
Oh. That's still pretty good, though. Yeah,
it's a rubbish joke. But anyway, so it will, when we come back in a different universe, we might be able to talk about this thing with its planets rather than just protoplanetary disk. Although it has to be said, and this is a footnote to the phys.org piece that's on the web about this issue, that both Hubble and Webb would possibly be capable of detecting whether there are planets actually already forming in the protoplanetary disk. And that would be a sensational observation.
It would be. Let's assume for a moment that we're going to go back there and find a planet like Earth with intelligent beings. How much far beyond the planet formation point would we have to add?
I don't know what that question means.
So, all right, okay. You're saying that it's 10 to 15 billion years to form a planet?
Maybe. Well, actually, no. No. It's million years, not billion.
Million. I keep doing that.
Yeah.
Okay, million. But then how much longer before life might be able to form?
Okay, all right. Well, so our life started, we believe, on our planet about 3.8 billion years ago, and that's so that's 900 million years after the formation of the planet. Okay, so
a bit longer.
Yeah, it's a bit longer. That's right. I mean, it's got to settle down. Young planets are pretty terrifying places. You've got lava worlds, and it's quite hard for microbes to breed in lava that's at temperatures, more than 1,000 degrees. And for a while, the Earth was a snowball as well. It was completely frozen. So our planet has gone through some extraordinary periods, and yet there is still life on it.
There is indeed. Yes. All right. If you would like to read that story, you can get it, as Fred mentioned, on the phys.org website. Just search for the title, Astronomers Find the Biggest Known Batch of Planet Ingredients Swirling Around a Young Star. Did I say that slow enough? But yes, that's where you'll find it. Fred, that wraps it up. Don't forget, if you would like to follow up anything, you can do that on the show notes. If you're following us on YouTube, don't forget to hit the subscribe button below. Visit the shop while you're at our website, spacenutspodcast.com or spacenuts.io, and you can send us your questions via the website as well. Thank you, Fred, as always. It's been a great pleasure.
It's had its moments, hasn't it? It's always good to talk about all this stuff. And
Indeed.
Thank you, Andrew, for keeping me company. And we'll talk again soon.
We will, and we'll see you on the next episode of Space Nuts. And thanks to Hugh in the studio for sending me so many notes. I couldn't read any of them while we were recording. So I'll catch up with that in a minute. And from me, Andrew Dunkley, it's good to have your company. See you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.